Example 2. We have the integral from 0 to 1 of e to the root x divided by root x. So we first of all need to recognize that we have a vertical asymptote at 0 because we're dividing by 0, and that the bound, one of the bounds, is the vertical asymptote. And since we have a bound at a vertical asymptote, we can see kind of up in this area here that it is unbounded. Okay, so we're going to need to set up an improper integral. So I'm going to use a limit. So I'm going to use a limit, and I'm going to use a variable a, and a is going to approach that unbounded integral, the vertical asymptote from this side. So I'm going to approach 0 from the positive side, and it's going to be the integral from a from the positive side to 1. So 1 is my endpoint, and that bounds the right-hand region there. And we have e to the root x over root x dx. Okay, so now I can integrate this expression, but to integrate this expression, we're going to need to use substitution. So I'm going to have to set up a substitution here. And I need to recognize that the inside function, square root x, is going to show up as a derivative on the outside as 1 divided by root x. So this is how I'm going to choose my u. So I'm going to let my u, my inside function, be the square root function. And that means that the du becomes 1 over 2 square root x dx. And what I've done then is I have my inside function, and the derivative is showing up on the outside. So the derivative of that is showing up on the outside, and I can replace that part with a u. So making this a little bit neater, I'm going to do 2 du is what I'm going to replace, and I have 1 over root x times dx, and that's the part that I'm going to get rid of with a du. So I'm going to then use my limit as a approaches 0 from the positive side, 1 over a to 1, and then I'm going to replace that square root with a u, and then I'm going to replace the 1 over root x dx with a 2 du, so I'm going to times du, and then I'm just going to bring that 2 on the outside of that because I don't really need to involve that in all the 2 because it's a constant. So there it is. I'm going to now integrate this expression. So I have 2 times the limit as a approaches 0 from the positive side. The antiderivative is going to be e to the u. Okay, and my bounds are going to be, and I forgot to change my bounds here. I have to make sure that it's clear that this is when x is equal to my bound a, and x is equal to my upper bound 1. And x is equal to a, x is equal to 1. Okay, and then what I'm going to do then is I'm going to replace this back in terms of x. So 2 times the limit as a approaches 0 from the positive side, e to the square root x, and then now I have my bounds from a to 1. And I can then plug in my bounds, limit a approaches 0 from the positive side. This is going to be e to the square root 1 minus e to the square root of a. And then I can plug in once I've done that, I can now evaluate this limit. It's 2 times e to the 1 minus e to the 0, or 2 times e minus 1. Okay, so that value there, this is units squared because it represents that blue area that I've shaded in here. And that is the as we approach the vertical asymptote, that area to the left is unbounded. So here we have the integral from 0 to 1 of 1 over cube root of x. Again, we need to recognize that we have a vertical asymptote involved here, and we are integrating to that vertical asymptote. So we need to use, this is an improper integral, so we need to use a limit to do this formally. So I'm going to set this up as a limit. So the limit, and I'm going to use the variable a as a approaches the left bound. Okay, I'm approaching it from that side, so from the positive side. This is going to be the integral of a to 1. A is my lower bound, 1 is my upper bound, and I'm just going to write this with a negative exponent. Just makes it a little bit easier to anti-differentiate. Okay, so there's my integral. I can now use an antiderivative to evaluate the area under this integral. So the limit as a approaches 0 from the positive side, using the power rule, I'm going to end up with x to the 2 over 3. So I'm going to add 1 and then divide by the power 2 over 3. Dividing by a fraction, I'm going to flip it. So I'm going to multiply by the reciprocal. And then this integral is going to be evaluated from the lower bound of a, which is going to tend to 0, all the way to 1. I can now substitute in limit as a approaches 0. And I'm going to substitute in, actually I'm going to take that coefficient on the outside here, so I don't need to worry about that. And I'm going to substitute in my bound, so it's going to be x. I'm going to plug in the actual value. It's going to be 1 to the power 2/3 minus a to the power 2/3. And then I can evaluate my limit. So 3 over 2. I'm going to plug in my a going to 0, so I'm going to plug in 0. Okay, so 1 to any power is 1, 0 to any power is 0, so we end up with 3 over 2, 1 minus 0, which works out to be an area of 3 over 2 units squared. So this area in here is going to be about 1.5. And again, if we take a look at, the grid markings here, you can see that this rectangle here is an area of 1, and then the remaining area that we see, yeah, that's about half of what I see in that square. So that does look like it's approximately 1.5.